advancing topic to go forward to the last pitch of the day, which is Nick Rothwell. Why I mention this? Because Nick is a composer, performer, coder as well, and he worked a lot with contemporary dance in that context. Some names include Shabana, yeah, yes, Jayasingh Dance, Studio Wayne McGregor, Ballet Frankfurt, Vienna Volksoper, Flamenco. He also works with algorithmic visual installation artists, Simeon Nelson Studio, Nesta Future Fest, Body Data Space. He's also a reviewer for Sound on Sound, which is a magazine that we all know probably, and is part of this project called Kayal Geometries, which is a live coding collaboration with sitar player Shama Rahman, which I think is also here with us attending the meeting. Welcome, Shama. And so let's start with Nick, which will tell us something more about JavaScript again today.
Okay, yes, all about JavaScript and stuff. What I'll do, though, is I'll start by releasing the meeting chat with a few links, which you can bookmark and, I guess, look at your discretion. So, home website. Oh, let me share. Let me get the sharing going here. Let's share sound and there. Okay, so home website. Oh, that's a Bandcamp. Home website is just a blog. So if you want to look through this stuff, feel free. I'll just grab the URL now and put that in the chat. You can't do this backwards by doing all the links first and the talk second, but never mind. As mentioned, Kyle Geometries, which I'll come on to in a bit, is myself and Shama, who is in this room with us. We've got links to Insta and Vimeos and things showing some of our performance work. And I guess finally I should plug my Bandcamp as well, although I don't have a link to it here, so I will do that at a later stage. Let me get the Kyle link in there. Give me a second. Okay, so the topic of the talk really is how to cheat at live coding, because live coding is kind of hardcore. It's people making live performances on stage by starting with an empty canvas and creating like Super Collider code or Haskell code from scratch. And I've tried bits of that and I've been not very good at it. So I decided the best thing to do is just kind of cheat. And well, as a giveaway, if I open a Max patch here, you'll see kind of what the cheating looks like. I'm sure you know that Max can host VSTs. So my approach to live coding is really Max patching, opening VSTs to do all the hard stuff like make sounds, play polyphonically, create reverbs and so on, and then using Max as an audio mixer and a sequencing engine. So Max is kind of the framework around this thing. And then the VSTs form the actual, the audio part of it. And when you host a VST, you see here you get a whole bunch of parameters, generally ranging between 0 and 1. That's kind of the VST standard. And you can just plug in, I got the code here, you can plug in different VSTs as well. So you can just swap a VST inside this holder and it just kind of swaps one out and swaps a new one in. So that's kind of the Max side. Let's start leading into the live coding side. So talking about JavaScript, there's several ways JavaScript will fit into Max. The old way, kind of the old tried and tested way, is this thing called JS and JS UI. That's been there for at least 10 years, I think, probably longer. And it runs a very old dialect of JavaScript in a very constrained environment. It can do graphics of various kinds. It can do some simple messaging, but it can't really kind of talk to the rest of the world or do anything that modern JavaScript can do. But more recently, Max can actually host Node.js, a node server. which is an engine for running JavaScript and doing networking and loading JavaScript libraries and doing a whole lot of other stuff which plain old JavaScript can't do. So if I just open this patcher here, where did I put it? That one there. Then what we have here is Max Patcher. There's our node engine sitting in the middle there, node.script. And it's got a debugging window at the bottom so we can see what it's doing. And I've got a Max dictionary attached here as well, called X. So that's the extent of our patches. In terms of the code, well, I'm not a great fan of JavaScript. I think it's an absolutely god-awful language, full of design mistakes and gotchas and really nasty corners. So this is all coded in ClojureScript instead, which is a variant of Lisp that compiles to JavaScript. So JavaScript is the essentially the machine code of it. And if I fire this up, I can kind of show it working. So the way this works is we can fire up a network server that can compile the ClojureScript into JavaScript and pass it through to the node engine here. So I can start the server up here. It'll take a few seconds. And once that's running, I can start the node script as well. And you see something just kind of ticks over here. And now what we have is a network we call a REPL, a read eval print loop, where we can actually execute bits of code as if they're in the editor here. So I can just execute that, and I can execute that, I can execute that. Oh, even not. What happened there? I'll just reload that again. Well, I appear to have crashed my node server. That's what we like. Proof that the demo is live. Let's try that again. Okay, one more time. Interesting. This seems to be utterly broken. I have no idea why. Right, this might bring this demo to an abrupt end. Let's see if anything else is working. No, it's not.
It's the live performance effect.
Live performance, yes, indeed. You know what? I should go complete restart the Max here. And if that doesn't work, then I will move on. Let's see where this gets us. Right. One more time. Nope. Really interesting. This was working absolutely fine a few hours ago. And it's telling me why? No, it's not. Okay, so what I was going to show you, which I can't because it's not working, is that this node.script object here, it doesn't talk directly to the Max patcher. We can't directly pass messages in and out. They actually go through a network connection, which means there's a degree of latency and a kind of a decoupling between the scripting object and the Max object itself. So you can't just fire a message out of here and expect it to take instant effect. It's kind of decoupled. So a lot of the coding around the closure here is to deal with the fact that you have to fire off these things asynchronously. And JavaScript is kind of bad at doing that. You get into a whole mess of using callback functions and messy mechanisms like that, or using async functions, which is kind of slightly cleaner. And the way around it in Clojure is you can do it with communications channels. So you can send stuff into channels and read stuff from channels. And this is an absolutely wonderful demonstration of that, but it doesn't work. The other thing I was going to show you is the fact that you can build max dictionaries and turn them into closure data structures and then convert them back again. But again, it's not working, so I'll move on. I'm getting a bunch of audio feedback from somebody. Is there a microphone open?
Oh yeah, please guys, mute your mics.
Okay, so let's cut to the main event here. So I started building this system probably about 4 years ago. And at the same time, I was working with Shama, who is in this room, essentially trying to put together a music project that would combine electronics processing and sitar playing. So sitar plus electronics. And then somehow we managed to land ourselves a gig in Berlin, playing at a functional programming conference. So we had to suddenly kind of get our act together and develop some kind of live coding system really quickly, hence the cheating at live coding, and build an environment where we could process the sitar music and kind of improvise with it. So it ended up being quite a large patcher, which I will open up here. So going back to what I was saying about hosting VSTs, this thing is essentially a host of a whole bunch of VSTs, mostly effects processes. There are some sound generators in there. So a VST processor and a matrix mixer, so that anything can be fed into anything, and a little step sequencer, and a host for the VSTs. So again, I should be able to, if things do not fail, launch this thing and get it all working. So let me have a go at that. Okay, so far, so good. So again, even though it looks like I'm editing stuff in the editor here and evaluating it, this is all going across into Max, into the Node.js that's running in here, and then back out again. So I can pretend to be coding in the Emacs editor here and inside the script, inside the language, but in fact it's Max that's doing all the work, or the node inside Max is doing all the work. So if we want to be kind of true to the live coding ethos here, we want to kind of be doing most of our stuff inside this Emacs, as if we are live coding for real, rather than hacking about inside the Max code. So it means we need to be able to do things like, for example, see what VSTs are loaded and see what parameters they have. So if I kind of run down here a bit, we've got controls for opening and closing the VST windows. That's kind of an absolutely worst case scenario. If things are going completely wrong, then we kind of give the game away, prove that we're not live coders after all, because we're kind of showing these windows. So we can turn these things on and off. What we can also do, if you call back that first patcher where I had the VST parameters, we can actually ask our node process to interrogate VSTs and tell us back what parameters they have. So that's me just interrogating one of the built-in synthesizers here. And let's have a look at what's inside that. And you see a whole pile of stuff in there. So that's stuff that's come back. Again, asynchronously, we have to kind of wait for the messages to come back. They don't come back immediately. And that's told us that we've got, what have we got in there? We've got, well, the usual filter settings, oscillator settings, LFOs, modulators, so on and so on and so on. And I can also do the same for, let's look at the loop as well, interrogate that. And then see if we can do a deref on there. And we get a whole bunch of other stuff as well. Or we can actually search these parameters in terms of names. So I can say, right, let's find all things that match LFO. So what LFO parameters have we got here? We have a bunch of those, including filter, LFO settings, LFO mod settings, etc., etc. Our little Enzo linker here has a handful of parameters, I think. Hang on, I just messed that up, didn't I? Let's go back to that. There we go. Something called link speeds. And what modes has it got? Well, I can load them into the dictionary. So rather than print them out in my editing environment, I get them loaded into my Max patcher here so I can look at them. And the final thing we have in here is a little step sequence as well. And this idea really came from the work on Gibberwacky, Graham Wakefield, and Charlie, whose name I have embarrassingly forgotten. Charlie Roberts, there we go. Because they built this environment where you could run a Max for Live environment with Node inside it and program it by live coding JavaScript from a browser. And I thought, yep, that's a nice idea, apart from the JavaScript part, because I've been using Clojure for a while, so I thought that's a nicer language. But this idea of step sequencing by live coding seemed like a good one, using the Max transport for doing that. So that's kind of what we're doing here. So we've got a sequence pattern we can use. And then hopefully we can just start this thing running without anything serious going on here. No, that's looking good. And down to one of our synthesizers. So I'll open the window on that so you can see what's going. And turn the audio on. So at the moment, nothing much going on, partly because we've got nothing coming in to our matrix mixer here. So we cut back to that. What we've got here is a bunch of inputs at the top and a bunch of outputs at the bottom. This kind of pretty object here is fairly new, and I've forgotten what it's called. Patch chords, I think, where you can attach inputs to outputs. Many years before that. Sorry?
Crosspatch.
Crosspatch, thank you. I knew it was something patch something. It's fairly new, but a good 8 to 9 years before that, maybe longer, I built a kind of a matrix mixer to achieve the same effect. So we've got both of them side by side here, which means we can do things like mix up or mix down parameters. What I'll do as a simple demo is just mix up that synthesizer here. And I've got delays in here as well, so you can do gradual mix-ins and mix-outs. And then hopefully, right now the sequencing patterns is just completely empty, so no steps in the step sequencer. Let's just add a very simple one here. So we've got one note in there. It's a particular C, below middle C, I think, with a certain length and duration. And there we just get our very, very simple notes being bashed out all the time. If we actually look at the sequencer window, let's come back to that. Then there's all the machinery going on behind the scenes. And again, because this is quite decoupled, because when you fire something into Node, you don't get the results back straight away. You've got to actually, just like Gibberwacky, prepare your notes in advance. So rather than say, right, I've got a certain timestamp here, now I play my note, you've got to say, I've got a certain timestamp here, therefore I'll prepare all the notes that are going to be played 1 beat from now. And we throw them into a sequencing object in Max. And then the next beat that comes along, we prepare the ones for the beat after that. So we're always pushing our sequencing data into the future. So there's a very, very simple pattern. A more complicated one. I should say in passing, we can also sequence VST parameters as well. So I've got a mini-moog filter there and actually sequence a cutoff just in the same way that I can sequence the notes. Somewhere in here, there's a slightly more complex note pattern. And there are beats in the bar, 1, 2, 3, and 4. And for each beat, we can say inside that beat that the beginning of it 0, halfway through it, we can add more notes. So if I just blast those in, we get something a bit more sophisticated. Let's just turn that off again. That's my initial def. There we go. And off it goes. So yeah, that's about all I've got to demo, because like I say, this code is really old and I'm not sure all of it works, but enough of it works there just to give you a kind of flavor of what's going on. I can try one more time to get the other code to work. I might just do that. If it doesn't, then we'll kind of give that up as a lost job. So let me just close this down. I'll quit Max one more time. I don't want that. Nope, totally dead. Okay, this is a very short talk, and I think I'm done in that case. Thank you for listening.
Thank you, Nick. Thank you. That's a very original approach to live coding, because I mean, I usually see people live using live coding for very specific tasks, and most likely relying on I don't know, like stuff of live coding which is out there, and it became a sort of I don't know, habit, like we were talking before about tidal cycles with someone else, or Orca, which is the weirdest I've ever seen. But I see that in your approach you handle pretty much everything about the performance through this kind of artifact. Like you handle the routing, you handle the calling or recalling of different VSTs. It's quite a job. And yeah, cool.
Well, I
Thank
guess
you.
there's a natural question here, which is, why am I not doing all this stuff in Max for Live? If I want to host VSTs and mix things and cross-patch things, that would make absolutely perfect sense. And I looked at that, but the problem is that the way that Max for Live organizes its files when you build Max devices is kind of opinionated. It starts building Max projects and wants things to be in certain places at certain times. And the way that the cross-compiler for Clojure works is that it wants its files in a certain place as well. And it proved to be very hard to actually get the two to coexist together. So I thought, right, we'll dump the Ableton side and we'll just do our own hosting and run our own Max transport and build our own mixer and kind of do it by hand.
Yeah, I totally agree with this perspective. Probably for another experience, because I don't really do live coding, but um, I like the approach of using coding to reach out to those kind of results that we are kind of we don't have access to, because we are inside a pretty coded framework, which is already there, and and it has its own rules. So I totally understand the reasons behind this. So guys, we wanted to share the project me and Stratos were talking about, which is this CC0, an installation, both web installation and physical installation, that we presented under the name of Participative Audio Lab. which is not just our project, but it's a collective of people with a coordinator